Right here I'll give you detailed solutions of my third module paper, Applied Maths Structure Type. It is there in the, you can see the newcomers or new viewers, the previous video I published in my this channel. You can go through and see the question 10 problems, structure type. So first question, the three particles A, B and C. Three particles A, B and C of masses m, em and e square m kept along a straight line on a table. So first particle A is projected with the velocity u, which is collide with the B, later B collide with the C. So the question is show that the velocity of C after collide with B is u. We will show C goes with the velocity u after the second impact. This is the problem you see all the applied part 2 structure paper. First question, mostly the previous many years, this direct collision problem between the spheres. Okay, so I have shown impact between A and B. A comes with u, B is rest. After collide we show usually the impulse I here equal and opposite along the common normal. Here I. I said after impacting A, move with velocity v1, B is v2, right? So here v2 is enough because v2 is the speed of B after impact. If you know the v2, we can work the B and C impact later. Here two collisions, just to complete this part. So direct impact problem, we are using the principle of momentum and the Newton's restitution law. So I apply the principle of momentum for this first impact that side. What is principle of momentum? Initial momentum equal to the final momentum. Momentum means mass into velocity. So final momentum here, mass m v1 for the particle of sphere A plus other one is em mass velocity v2 equal. Initially only the A has momentum, B 0 because B is at rest. So here mass is m into u. So here I can cut by m is a common factor. So v1 plus ev2 equal to u, right? I say first equation. Next we apply Newton's restitution law for this first impact. What is Newton's restitution law says? When two particles or collisions happen along the common normal, velocity which is separate velocity is coefficient of restitution into approaching velocity, no? Or the ratio is E, because I hope you learn complete in that syllabus, the theory part. So separation velocity equal E into approaching velocity. So what is separate velocity here? V2 become the larger than V1 because it's hit that it's go rushed very faster than this. Therefore V2 minus V1 equal coefficient into approaching. Here the approaching diagram only the U, other is rest. Second equation. That's all applied maths part here. Solving is pure mathematics work. Solve this, find the V2 enough. So if I add the both, add the 1 and 2, so if I add the 1 and 2, add the first two equations, then V1 cancel, take the V2 out. If I take the V2 out, there is 1 plus E into U, is it? 1 plus U into U, 1 plus V into 1 plus E, V into 1 plus E. The other side at the both, take the U out, 1 plus E. Cancel V, what is that? At the both V1 cancel, V2. V2 equal to U. That means after first impact B moves with the velocity of U. Now we take the impact between B and C. between B and C. Same idea follow. C is at rest. This is moved by U. That's V2, that's U, right? I put now V2. ICS goes by V3. This is V4. Okay. Also, if I show complete method here, J, different impulse. I say J. Some question they ask, find the I value, find the J value. Okay. So I apply the same method, principle of momentum. So your mass is Em. This is E square M. So apply the principle of momentum for the second mole collisions, that direction. Final momentum Em into V2 plus E square M into V4. Final momentum, mass into velocity plus mass into velocity, equal what is initially V2 and the mass Em. So Em into V2, you can cut by the Em common factor, divide by Em. So V3, here 1E remaining, V4, here V2. Okay, I said my third equation. Now Newton's restitution law, right? Is apply the Newton's restitution law as I shown briefly first part. So separation velocity V4 bigger than V3 equal coefficient into V2. Say number 4. Now we have to calculate the V4. Find the speed of the particle or sphere C. Therefore, to find the V4, once again add the both 3 plus 4. So what happened at the both V3 cancel. Take the V4 out, 1 plus Z equal, take the V2 out, 1 plus Z. So 1 plus Z cancel, V4 equal, what is V2? U. That is true. So I hope you successfully complete and you check with me, correct it. If any problems, stop, pause the video, recheck your answers. Okay, second question is the position of a projectile. Projectile problem. Projectile launched from the origin P equals 0 is given by a position vector model. The projectile equation provided in terms of a vector model. So the idea is second question. This is I vector or the x-axis. This is the j vector or the y-axis. Here say here time is 0. Time is 0. If I take initial speed is u. So they mention after time 2 seconds. After 2 seconds, its position vector. I mark somewhere here. Time is 2. After 2 seconds, its position that is given as r. Vector r is given 3ai. Vector r is 3a vector I plus vector b. This pattern, right? 3ai plus vector b after 2 seconds, right? If the projectile was launched an angle theta with the horizon, the projectile angle is theta, then show that tan theta answer, right? So what do you mean this position vector? It's the displacement vector after 2 seconds. What do you mean ij component? Here j. But the ij component therefore, horizontally 3a distance after 2 seconds, vertically b distance, right? Therefore I can mark this. This is B, this is 3A. After 2 seconds, particle actually travel horizontally 3A distance, vertically upward B distance, right? Therefore we need the tan theta answer. So we apply suitable formula. The initially U is given, but the answer no U I mentioned should be there in the projectile velocity there. So we apply what S equal UT, that formula, and check whether using the initial and the final part here. So apply S equal UT plus half FT square from initial to after 2 seconds. From first 2 seconds apply this formula. First I apply horizontally. What is displacement? 3A. Okay, 3A. Horizontal speed U cos theta into what is T after 2 seconds, therefore T for 2. Otherwise this 3A equal 2U cos theta. I said my first equation, you know that horizontally no acceleration, therefore this part is 0, right? This part is 0. This is under gravity motion, no horizontal motion. Next apply upward displacement or above the projectile height, B distance, right? B equal, what is velocity here? U cos theta, then U sin theta. U sin theta into T is 2 minus half G T square, 2 square, right? So the idea is tan theta. What the idea? Tan theta comes the answer. Sin divided by cos is tan. Sin divided by cos is tan. Therefore I keep the sin part here, take other here. So B, here you can cut the 4 cut by 2, so minus 2G, this side take plus 2G, here what? 2U sin theta, right? Second equation. So we will get the answer by removing the U. The answer no U, no projectile velocity, not projectile velocity. Therefore if you divide, what happened? Divide 1 by 1, U cancel. Answer tan theta, no, therefore divide sin divide by cos. So second equation divide by the first. Second equation divide by the first. Second one is 2U sin theta divide by 2U cos theta. The other side B plus 2G over 3A. So is the answer tan theta equal B plus 2G over 3A. Therefore theta equal tan inverse B plus 2G over 3A, right? It's the answer. Provided a structure type possibilities for a this is the structure model. First is impact problem, one problem comes later under projectile. That question, right? So I hope you work, check with this, and any problem recorrect it. Maybe any method is one of the method, right? Using the question vectors given. There's no any vector model, no any huge vector idea. Only the idea along the I component what distance, J component what distance. Okay, next question number 3. A vehicle of this under the work energy power problem, one of the structure model you see in the many papers. A vehicle of mass capital M and the engine power is capital H kilowatt. So in this problem, very easy question, but if you misuse unit conversion, should be meters per second speeds, and the power should be watts, not kilowatts. If they given the kilowatt, you say initially 1000 watts. So the vehicle H kilowatt power is moving horizontal road with a constant velocity 2u kilometers per hour. 2u kilometers per hour. The resistance force to this proportional to this ordinary method. You properly learned this work and power energy form. If I show the idea, let's try it road. A car or a vehicle of mass is say capital M. So its resistance is given R. So if I say it's the velocity, they say 2u. Velocity is 2u kilometers per hour. Should be changed to meters per second, right? And they say constant velocity, uniform velocity, therefore acceleration 0. Therefore acceleration F0. And what another thing? They mark that the resistance force is proportional to the velocity square, right? Resistance force to the motion is directly proportional to the square of the velocity, right? So this in this case R proportional to what? Velocity square. Velocity square. You know, when you equate the proportional, you put a constant. So R equal K into velocity square. So at that instant, what the velocity, its square is the resistance force. Also I mentioned the track force, the force pulling this vehicle, or tractive force P. It's the usual notation, right? The track force is P that by the vehicle. Okay. So very first I go to the change of the conversion. They mention where capital H, the power, capital H kW. The power is capital H kW should be changed to watts. Therefore H into 1000. Now what? That is 1000 H. That is one part here. 1000 H is the what? The power of the engine, this vehicle, right? And also what is 2u kilometers per hour? You know that 2u or u kilometers per hour. Change that unit conversion. U, but that 2u or u means 1000 meters and 3600 seconds. So if I mark that, in this case 2u equal to how? 2 times, what is u here? 1000 meters, 3600 seconds, converting to the kmh minus 1 to meters per second, right? So what is that? Simplify, 1 0 cancel and a 0 cut. You cut by 2 5, cut by 2 18. Is it 10 over 18? A further cut 5 over 9. Okay, 5 over 9 meters per second. 5 over 9 meters per second. If you transform that 2u into that meters per second, right? 5 over 9 meters per second. Okay. Next we come to that, therefore resistance force here R equal K into velocity here 2u. I mentioned that 5 over 9 into u also u, 5u. That's the velocity, right? 2u, no, 2 into u. 2 only I change. U is a notation shown here, right? Therefore answer 5u over 9 in meters per second. So its square is the resistance when I equate with the constant K. So it is 5u over 9 square, right? Check that this is okay. That's the resistance at the moment. Okay. So now in this case, this initially a vehicle moving along horizontal path, later it goes to the inclined motion. Most questions come under work power energy syllabus, that lesson questions, horizontal part. Why this horizontal part? To find the K answer. So just to complete the K answer here. So this resistance is okay. But the main important two formula or two equations that we are using in this such a problem, one is F equal ma. Newton's law equation, one special for only this chapter, H equal PV, tractive force equal power into that velocity. So let's apply F equal ma, apply Newton's formula F equal ma, horizontal, if I apply these horizontally, what horizontal forces here? P, that side, minus R, right? P minus R equal mass is M, that is in kilogram, that's in kilogram, right? Mass M plus kilogram, right? Mass into acceleration, that is 0, that is your uniform velocity. They say therefore exertion 0. Therefore clear is P equal to R, P equal to R. So the R is K 5/9 square. I say my first equation, P equal K into 5u square, right? Check it, that's the answer here. 2u completely square, 2u 2 times u all things square, right? Complete answer 2u all things. Next we apply H equal PV formula. The only one formula especially using is work power energy. The attractive force equal to force into this power equal to the force, attractive force into velocity. So here the power is 1000 H, right? 1000 H. P into velocity, that is 2u, that means 5u/9. 5u/9. Okay, say second equation. Now connect the both to find the K answer. Connect the both equation to find the K answer. Once you know the K answer, you can complete the future the model also in the inclined plane. So simplify both, find the K value. So connect the 1, 2 or 1000. I apply for P for that, right? 1000 H. P for that, K into 5u/9 square into once again 5u/9, right? Is in watts, 1000 H act as a watts. So what is K therefore? K equal 9 cross multiple and divide and see. That's cube. Now cube, that is cube, square and cube into 1000 H, is it? This is the constant here, 1000 H into 9 cube over the complete cube. So this is correct. This is correct one, you can go ahead. If it's failed, you can't go the inclined motion. Now what happens if the vehicle is traveling with a constant velocity of u kilometers per hour, right? With the same h, same power, once again same power, in a slant road, angle alpha upward. If I draw new diagram, now it is moving like here. So what is the force? Mass is m kilogram, so mg downwards, right? Mg. So here I said the attractive force is P naught. The car, it's machine work, P naught force, tractive force. And in this case, I say the resistance is R naught, different resistance R naught. Here they said velocity u kilometers per hour. U kilometers per hour. So what happened? U means there's no this two. If I show once again, that is what is u kilometers per hour means. Change it that u into what is that, 1000 meters, okay, you can take there from that part, over 3600 seconds. Okay, so what happened, 1 0 cancel, so u cut by 2, then 5, 5 over 8 is it? Is the velocity in this case. Here they say u, 2u, but here u, right? 5u over 18 is the answer. We cut by this. So here also acceleration 0, right? And we apply the question, show that capital H equal 20 over 63 mug sine alpha, but kilowatts. The problem is kilowatts. So we apply here. What happened? The resistance force. I raise this. I know the K value is enough. So I raise this. So here, what is P naught here? P naught equal to K times velocity square, proportional to its square. K is constant, or the vehicle model, the vehicle prepared, manufactured for such a K value where whatever is moved along horizontal or inclined plane, upward, downward, K is constant for the two parts of this question, right? Therefore now, so P naught equal, you know the K answer, K into, what is U is 5U over 18. Is it okay? It's square. U kilometers per hour, in this case 5U over 18, completely square, right? Right. Now we apply the both F equal ma and the other formula. Apply F equal ma, upward, but the force along the upward, P naught, upward, minus R naught, and mg component, right? What is that? Here 9 alpha, here 90 minus alpha, mg cos 90 minus alpha, mg sin alpha, capital Mg sin alpha, that's what the force, right? P naught and the R component, P naught minus R minus that, okay, equal mass m, but here also uniform velocity, acceleration is 0, right? Therefore in this case P naught minus R naught, can I take that is mg sin alpha, capital Mg sin alpha. I said my third equation, because we completed the first and two the earlier. Now apply the H equal PV formula. Apply the tractive force, the power equal to tractive force into velocity, right? So here are the same, H is same. I said P for P naught, you know the P naught, we apply the P naught. And velocity is U, that means 5U over 18, right? 5U over 18. I say my fourth equation. Now connect the all, the problem is find the capital answer. So for P naught I can substitute 18 H over 5U. Also I know the R naught, connect everything. So connect 3, 4. 3, 4. Here, can I say what is P naught? 18H over 5U. 18H over 5U minus R naught is that K 5U over 18, all things square, equal to what? Capital Mg sin alpha. Okay. Now we apply once again this k value. We put the k value there. So therefore 18h over 5u k. Put this k answer 9 over 5u totally cube into 1000h into 5u over 18 completely cube. Okay, the square, so square equal to capital Mg sin alpha. Very important, simple question. If you miss little bit any common error, if you had a mistake, it's difficult to rearrange, recollect. You have to be careful, properly show these expressions. Now try to simplify. Is it okay? 18h over 5u minus k for this 9 over 5u cube, 1000h and 5u square, that's right. Now simplify the model, take a method here, 18h over 5u. Here try to simplify any method. See this 5u square completely. Here cube, there 1 5u below, is it? Okay, 1 5u below. Here 1 5u, right? 1 5u is below. Here complete square. Here cube, therefore below. And 9 cube. That also you can simplify thing. And 18 square into 1000h equal to mg sin alpha. So here 9 here 18, cut several 9s here, 18 square. So here 18h or 5u. How that? 18 into 18, cut 1 9 2 times, cut 1 9 2 times, cut another 9 2 times. So 4 here, 20 here. Check that 20u, right? Here 1 9 remaining into 1000h equal to mg sin alpha. Now simplify 432. You can get these all answers. Take the h out and 1000h. The problem, find h value. So if you rearrange, you can get the answer. H equal 20 comes here, 20. Therefore 72 minus 9, that is 63. Check 63 over 20u into mg sin alpha. So 1000 h convert to kW, it becomes answer k into w, kW, that answer. So rearrange, get the h value just there, right? Okay, that's the next question. So 3 problems solved. First one impact, second projectile, third one work, power and energy. And for those newcomers, you can see this channel. I already published that before 3 days. Third model paper structure type. Question 4. Position vectors of 3 points A, B and C are provided. If the points A, B is the vectors, I separately I publish many vector videos. I try to complete 30 essay problem with the structure also. I complete 8 videos of vectors. So in the 1 video I complete all questions. So here, with respect to origin, if I say, oh, here is a 3 points, right? O, A, B, C. So question vector if A is 2i plus j, 2 vector I plus vector j, and the vector B I plus 7j, I plus 7j, and the point C 5i minus kj, 5i minus kj. The question vectors are given in terms of unit vectors I and j. If the points A, B, C are collinear, find the value of k. We should find the k. Then use the ratio that CA and AB that is later. First we complete the collinear idea, find the k value. So what the meaning collinear along a straight line? We worked many ideas in the previous my videos. So you find the AB vector and find the AC vector and take a ratio between AB and AC. You can get an answer for that, lambda times or like that. So there is, take triangle, in triangle OAB, in triangle OAB, what is AB vector? AB equal what? AO plus OB. AO plus OB. Okay, so what is AO? OA is 2y plus j. Therefore, AO is minus into 2y plus j plus OB is I plus 7j. So what is that? Minus 2y plus I minus 1i minus j plus 6j. Okay, this is AB vector minus I plus 6j. You find I minus 0. Okay, AB vector. AB equal AO plus OB. AO is minus times that and OB is I plus 7j. Therefore minus I plus 6j. Okay, now we find the same AC vector. Come in triangle. Take the last triangle AOC. Triangle AOC. The triangle AOC. What is AC vector? AC vector what? AO plus OC. AO plus OC. AO plus OC vector. So therefore, what is AO as earlier? Minus times 2i plus 7j plus j. What is OC vector? 5i minus kj. And now the k involving. So we simplify, that is 3i, 3 vector I, 3 vector I. And take the minus k, minus out, it becomes k plus 1 into j, right? Minus kj minus j, right? Now you can write a sentence. They mentioned that if A, B, C are collinear, if A, B and C are collinear, so then we say let AB equal, AB or AC, whatever, AB equal lambda times AC. The collinear idea, AB equal lambda times AC. Otherwise, AC equal lambda times AB, no matter, right? Where lambda is a constant. So apply that AC for AB for what? Minus vector I plus 6j lambda into what is AC here? 3 vector I minus k plus 1 vector j. So you work many questions on the vectors. Now both sides equate the coefficient. Equate the coefficient. Equate the coefficient. I coefficient What is I coefficient both sides? Here -1. Here 3 lambda. 3 lambda. Okay, if I say first equation. Now J coefficient. Here 6J, so 6. Here how many J? That's minus times. Minus into lambda K plus 1. Second equation. Okay, right. So now find the K answer. First you remove the lambda, divide 1 by 1. If you divide the second equation by first, here -6 it. Here what? Lambda cancel. Minus into K plus 1 over 3. Okay, so both side K cancel. 17. Check that. K is 7. If you work K equal to 17, the constant K value becomes 17. And you can tell the answer. The question is there have a ratio between CA, AB ratio, CA, that AB. You know lambda. Now you need the lambda value. Here lambda is -1/3. Is it lambda is -1/3, or sometimes you have positive 1/3. No matter, the direction only change. And my first equation, lambda equal -1/3. Then go to the answer. Let AB equal lambda AC. No? Therefore, AB equal, I change the minus by change the direction, 1/3 of CA. Okay, let AB equal 1/3 of CA. This answer they ask CA is to AB, therefore CA is to AB 3:1. Check that, therefore CA is to AB 3:1, right? A simple, well-balanced question for a structure type. This is the answer for that. Okay, let's see next question number 5. It's under force diagram but friction question. A heavy uniform rod AB of length 2A is kept in equilibrium with the end A is against a vertical rough wall and the other end B attached to the by light inextensible strings 2A connect to swing. I hope you work that idea. So it's the vertical wall. So a rod is kept by touching the wall and other extreme connect to the wall once again by other threaded by a long string, unextensible string. How the diagram therefore is it like this? If I zero point A here, B here, and they tie this point and attach to the wall, right? This is uniform rod AB. So it's a weight at its midpoint. There's a length is 2A, rod is 2A length. Therefore each 1A, here A, here A. And what are the forces act here? Force diagram is important. What are the force act here? String. So here they mention is the point C. Point C here they mention. So this is tension T. And what? Here what happens? Slip. Rod will to slip downward. Rod slip down because friction, rough wall. Therefore friction oppose F. Friction oppose, right? And the reaction exerted by the wall, perpendicular reaction are. There are actually here 4 forces: friction, reaction, perpendicular reaction. They said this also 2-way, string also 2-way. Therefore this is an isosceles triangle. So if I say this is theta, no doubt this is also angle theta because of isosceles triangle. Okay, so four forces are there, W there, F there. So we can reduce into 3 forces. Our questions are the 3 force diagram. So what are the 3 forces? Tension you can't change it. Weight also you can't change it. But you can change. There's another additional we call resultant force between reaction and the friction. Between reaction and the friction, resultant force available. If I show that one, it's maybe like this. Resultant between these two, therefore we avoid the F and R. I say this resultant. Therefore the third force W also should be passes through this point. The 3 force idea I complete there. W is a force, T is a force, and later R and F available, right? Now what the question is, if the system is in equilibrium without slipping, right? It can be slip, they say no slip. It's be perfectly equilibrium. Then show the coefficient of the friction exceeding mu greater than 1 over root 3. So we have to show that the coefficient of the friction exceeding 1 over root 3. So I hope you know what is mu. FOR, friction force divided by the perpendicular reaction, gives you the mu value, coefficient of the friction. Therefore try to solve this diagram to find the F and R. Here this force not necessary, but I shown the 3 force method. W also should be passes to that point, right? Okay, they say any other. Yeah, the rod makes an angle pi by 3 with the upward vertical. Therefore I mentioned theta is pi by 3, right? They said this is pi by 3, 60 degrees. Then isosceles idea also pi by 3. Then we find the force. So therefore you can write for equilibrium of the rod. For equilibrium of the rod, resolve upward for equilibrium of the rod. F upward, W minus W. Okay, what the T component here? Pi by T cos pi by 3, right? Upward plus T cos pi by 3 equal to 0. Your first equation. F upward, W only down, then T component T cos pi by 3. Okay, then you can get the one equation here by solving this. So I keep this first equation. We have to find the F and R. F and R gives you the knowledge of the mu. F divided by R is mu, right? Next what? Find R. How? Divide horizontally. We solve the force horizontally. So R here, minus T this side. So we said T cos, therefore T sine is it? T sine pi by 3. T sine pi by 3, that's all. Second equation. That's all the applied work. Now solve and find the, here how many terms there? F there, T there, R there. 3 unknowns. You need the 3 equation. Therefore try to get another equation to avoid the F and R idea. What happens if I take the moments? Take about A. If you take about A the moments, take about A the moments, then no F, no R, no resultant also through this. T and W idea. Then you can find the T. You can find the T. And when you apply the T here, you know the F. If you know the F, then you can go to that answer. Otherwise, you remove that. Anyhow, you need to find the T answer, right? So this side F4R equal W. Take this side and divide also T cancel. That's a relation between F and R. But both unknown, you must find the T answer. So take moment. Next you write. take moments about A. For AB, take moments about A. And I take the T direction of the T, right? This direction, take T into, what is this perpendicular, if you take any from the line of action of the T, perpendicular idea, here 60 mean here 30, no, pi by 6. Okay, then think about if you draw a right angle line here, think this is 90, maybe this is 90. So 2a is cos sine pi by 6. Take the perpendicular height is 2a, here cos pi by 6, sine pi by 6. Check that. 2a t into 2a sine pi by 6. That direction. Minus w, opposite direction, minus w into other direction, where the A, this one, they said pi by 3 up, so, but the A cos pi by 6, is it A cos pi by 6, right? A cos pi by 6 equal to 0, right? 2a sine, A sine. Now simplify, complete the answer, find, you can find the T answer. Once you know the T answer, simply the value solvable. Okay, ideas. See, let's check pi by 6 how. If I draw here, this is 30, here 30. I need the perpendicular height to this, from T to this perpendicular height. I put here now. This part is wrong. Check this comes sine pi by 3. Check that sine pi by 3 is it? Sine pi by 3. Sine pi by 3, that component T into perpendicular height. I missed that. I missed that. Pi by 3, sine pi by 3. So what is that? Can A cancel? T 2t sine pi by root 3 by 2 is equal to W. This is cos 30 W by 2. Like similar method to cancel. T equal W by 2. Check that. T equal W by 2. T equal to W by 2. T equal W by 2. Then from the first equation, what is F equal? W minus TW by 2 cos 60 half. So here W by 4 is it? 3W over 4. 3W over 4. Next find the R second equation. R equal to T4W by 2 sine 60 root 3 by 2 root 3 W by 4. Okay. Next write a sentence for equilibrium. For equilibrium, F over R less than or equal mu. For equilibrium, F over R less than or equal mu, right? Less than or equal mu. Is it okay? This angle here 30, right? Here 30, here 30. This is 30. If you draw a right angle, it becomes 60. If you think this becomes 60 degrees, 60. If you draw a 90 degree, check 60. Then we solve. You need this answer. So hypotenuse given, opposite need. That's why that sine 60. Not I mentioned 30 is wrong. Sine 60. So for equilibrium of the rod, F over R less than or equal mu. So apply the answer F4 3W4. R is root 3W4 less than or equal mu. Check 4 cancel, W cancel. Check the answer. The given answer they are provided. Mu 1 over root 3 is it? You check that root 3. F over less than or equal mu. F is 3W4 root 3W4. Therefore mu less than or equal to 1 over root 3. That 4 cancel, 3 over root 3, W cancel. Answer provided exceeding 1 over root 3. Here above root 3 is above root 3, here cancel above root 3. So less than root 3. Check this is answer 1 over root 3 less than or equal. This is the answer for this friction problem.